So this was a nice thing which we did in the last 10 years. We ran this survey among the participants of similar courses, and we have been collecting and collating and analyzing the results of those feedback forms. So what it reflects is what people have input in those forms. Especially we will see how CAD and simulation has grown over the last 10 years in India. Okay. We will see what people report about what are the benefits and what are the problems or issues in implementing those software. So from that we can start seeing if we can do something about that. I'll also include in this presentation what kind of people actually filled up the form, what kind of foundries, what kind of methods, what kind of processes, what kind of rejections they are reporting. Now this is from an overall survey of not only these 10 years of survey, but also our own cases with different foundries. So an overall summary of that, if you round off the numbers a little bit, you have three major benefits and the numbers look like this. The number of foundry trials. If a foundry is typically making 4 to 8 trials for developing a new casting, it can come down to just 1 or maximum 2 trials per new casting, which means you are saving 75% of resources for trials, and that's a significant resource, because many times you are actually stopping the production to try it out because you can't wait, customer is in a hurry for the samples. Number 2, rejections. We have seen a very clear trend that by using simulation, rejections which were, let us say, 6 to 10% in most of the foundries which we see comes down straight away to 3 to 5%, which is a 50% reduction in rejections of castings. The third benefit which you see is a yield improvement. Okay. Sometimes you have seen both rejection or quality improvement as well as yield improvement, but usually it is one or the two. If some foundry says our rejection level is not very high, we immediately ask what is your yield, and then you find yield is little too low, and then you can say okay, let us optimize the yield. So typically 40 to 60% is a yield for most ferrous, SGR and steel and some aluminum alloys. If you find that, it improves at least by 5, 10, 15%, which means percentage wise yield improves by 25% on the initial, let us say 40, 50%. So there are three main benefits which you see, all of which have economic numbers. You can convert that, put a value to that, and if you see a typical 1000 to 2000 ton, you can say medium, small, medium foundry, the benefit, the saving is at least 8 to 8 million, means about 1 to 1.5 crores. It's almost like 1000 ton per year foundry will save 1 crore. Okay, it's almost equivalent to that. Okay, that is what our overall thing says. But now let us actually look at what is happening, who said what. So our 11 year survey actually now, we have total respondents is 304, so we hope to add another 40-50 today from about 250 organizations, out of which there are about 180 foundries, about 40 OEMs, and a few, when I say foundries and tool rooms, I think tooling also is included in that, and then about 30 consultants and researchers. Okay. Now what is the percentage wise? So if you see foundry 70%, tool makers a little, not very too many, 2% tool makers, OEMs good representation, 16% OEMs, and then academia, R&D consultants and so on. If you look at in terms of age profile, almost equally split between top management and middle management and that is a worker level, okay, engineers or worker level. So almost we have fair representation of in terms of seniority of the people who are, and remember when I say 1/3, you're talking about out of 300, about 1/3, almost 100 are senior management, up to about let's say GM level or foundry chief level and so on. What about foundry size? Again a fair, I know we are just lucky, I'm saying, I mean this is finally how numbers add up, you can't manipulate any of these things. Very nicely almost equal distribution of large foundries, medium foundries and small foundries. Okay. Now only location wise, because we are in Bombay, obviously you will find almost half the respondents are closer to Bombay, which means from the west. When I say west, it's, if you draw a line and say Rajasthan and Gujarat and Maharashtra and Karnataka, they're all west, and then you say, then you have east and south and north and so on. I mean extreme north, Delhi and above, let's say Coimbatore and below, we call it as south, and let's say Indore and or Bhilai and east is east, some kind of distribution. So obviously we have more from the west here. In terms of metals, it's again representation of what Indian foundry produces. So you see almost half, more than half a grey iron. Ductile iron, fortunately we got a good representation. Although actual production of ductile iron is less than 20%, we got good participants in ductile iron. Maybe it represents ductile iron people are having problems, and maybe they come to our courses to solve the problems. And aluminum also, I am very happy to see 30 people here, 30% here. Now the total of that may not be equal to 100, because many people are producing more than one metal. A particular foundry may be producing ductile iron and grey iron both, so the total may be much more than 100%. Similarly, if you see process, obviously sand casting takes the cake, 76%, but shell, PDC, GDC, centrifugal investment also, we got a fair representation here. And finally, in terms of application, although automotive actually accounts for 1/3 of castings in India, we get more participants from automobile, but maybe because quality challenges and cost challenges are far higher. And automobile, in fact, automobile industry is actually responsible for pushing the R&D scene also in the foundry industry. The maximum push, the pressure R&D comes from OEMs, automobile OEMs on foundries. So that represents in a sense, but pumps and farming and motors, electrical energy, machine to railways, we have fair representation again from all major sectors. Only sanitary you don't find much. Sanitary sector, you don't find much representation, although they account for almost 15-20% of the total production in the country. But perhaps the quality requirement is low, they don't have too much of complaint from customers, maybe they're looking at grey iron, which is a very forgiving metal and so on. So we don't have much from that. Except for that, we have a good representation here. Now let's look at the results. So if you find here, you will find that over the last 8 years we have mapped it. Okay, 2002 to 2010, the first bunch of columns show you the web applications. Essentially, it's internet and email. So 10 years back, if you ask, are you using email and internet? Hardly anyone, hardly 1 in 3 foundries is saying internet email. Almost every foundry today is using email and internet. They have a website, if not a website, access to website, access to internet, and they use email for at least corresponding with their customers. The planning, like material planning and furnace charge planning and some production planning, scheduling, things like that, using Access and Access and things, Excel and Access and so on, that's also increased dramatically from below 30% to almost 70, 80, 90% today. So everyone is now using Microsoft Office for doing some planning work. CAD CAM also not too bad, okay, from 30-40% all the way to about 80% today. And here we say, when you say CAD CAM, we mean they need not have in-house CAD CAM. Even if they are outsourcing their CAD CAM, a modeling or CNC toolpath generation or CNC manufacturing, we say they are using. As long as they are using directly, indirectly, we count them in the users. So please remember, it is not necessarily in-house use, but also indirect use through collaborations or consultants. Simulation is where we see a different kind of picture. Okay. In fact, it's more or less constant at about 20-25% among the people who are coming to our courses. Please remember that. But if you see the countrywide, and we try to keep track of how many foundries are buying which software at what point of time, the total number of simulation packages in the country, if you see here, our total number of foundries is about 5,000. Less than 250 foundries are using simulation today. Only 5% penetration. If you look at USA or Germany, okay, the penetration or usage of simulation in foundries is much more than 75%, which means that 3 in 4 foundries are using simulation. Here 1 in 20 foundries, maybe 1 in 25 foundries is using simulation. Okay, so that's a big gap there. Okay, so that is the picture of simulation. Now then we also looked at, anyway we have among people who come to our simulation courses, we have people who already have simulation in-house, okay, either directly or indirectly through consultants, okay, or a cluster has access to simulation. So we kind of segregated, because in the questionnaire you will find what is your rejection level, and so we mapped the rejection level of simulation users and non-users. So if you see the blue lines are the rejection levels, average, please remember, average rejection levels reported by people coming to our course who said they don't have simulation. And the red ones are the average rejection rate of foundries who say they have simulation. If you take average across the years, across 10 years, average of averages, you will find that net average of rejection level among non-users is about 8.69%, and those who have used simulation, the average of average is about 4.3%, which means clearly you see a trend that it's directly is reducing rejections by half, little more than half. So you can't have any better proof than this, that averages cannot be lying too much. You have very good solid proof that simulation can reduce rejections directly by half. No matter what simulation package you use, doesn't matter, rejections can come down by half. Then we ask few more questions, and you'll find a nice table in which you have to tick mark, okay, or you have to put some numbers saying, okay, among the 5 type of IT applications we are asking, web applications, which means website, email, internet, and planning, and CAD CAM, and simulation, among the 4 applications, and let us say 5 different benefits. We are asking for, is it reducing cost, is it improving your yield, is it reducing rejections, is it helping you develop new castings faster, and are your customers happy? Among the 5 benefits, which is the number 1 benefit you got out of this package? So you have to rank them. You have to say rank 1, 2, 3, whatever. And if you count that, finally, you see these numbers. You see that most of them talk about, if you look at simulation, has benefits almost equally in all the things. But you don't have to be influenced by that. Please put what you think is right for you. But simulation does help in all the 5 aspects of that. Then we ask people, okay, fine, what are the problems in using simulation? And that's where we are very interested. Okay, simulation you have bought or you're using indirectly, what are the problems? And we've asked, at least in 4 directions, is cost a problem? Is maintaining the software, running the software a problem? Is there a problem with the technical support from the vendor who are selling the software to you? Is there a problem with the trained manpower availability and manpower issues there? And here you see a clear differentiation. We thought cost would be a major constraint here, but cost actually doesn't come as a major one. The major constraint comes actually as, in fact, number 1 actually is technical support, followed very closely by trained manpower, which are both are manpower issues, whether manpower in your foundry or manpower at the vendor who supplied simulation to you, both are manpower issues only.
What is this maintenance?
Maintenance cost is after 1 year software stops working for some reason, let us say. And it could have stopped because of various reasons. You have changed the hardware, the software compatibility is not there, or the vendor says you have to pay some maintenance cost, you don't want to pay because you didn't get any benefit out of that, various reasons. Is it running after first year or not? And the maintenance issues or maintenance cost are the, now this is showing as low value here, okay, but I'll tell you what, most of the people who come to our courses are people who have bought simulation in the last few months, because they come hoping that they know how to learn how to use it better. What they do not know is that maintenance can be actually a biggest nightmare among everything else, because you have all kinds of issues with software. It's like any other machine, it can stop working and you have to figure out why it's not working. And unlike a machine, if a machine stops working, everyone comes to Foundry and asks why it is not working. If a software stops working, you cannot even see that it's not working. It's invisible. So people forget about it. So it's actually hidden. It's like cancer. You stop working, you paid money onto that, you forget about it, unless some boss remembers that. But by and large, the major problems, and even maintenance I can see, is a human manpower issue again. You don't have the right kind of support or people to do that. So this is a problem that unless you have the right kind of people working in the foundries and you have manpower turnover happening all the time, the guy who got trained in the software suddenly gets a better job, he runs away or goes away. Now what do you do with the software? You have, let's say, put a few lakhs onto that, you have to train a new person, and the company says, okay, I can't train, then you are in deep trouble again. So either manpower issues, sometimes you have a very small thing, maybe the hardware lock which you have put is not plugged properly and software stopped working. All you need is a phone call saying it's not working, and someone has to ask you the right questions. Okay, did you plug this, did you switch on that, did you try this? It takes 5 minutes to fix the problem. But you should be able to know how to pick up the phone and ask the question. And here is where one big observation which we have got, which is not in the slides. When we looked at the market share of each of the software packages, I mentioned that some are from Japan and Taiwan and Sweden and, let's say, Germany and USA and all that. If you look at the largest number of licenses sold, if you find that typically about 70% to 80% of the licenses sold by a particular vendor is in their own home country. So what does that indicate? It indicates that the local language support is the most critical issue. Okay, Foundry people all over the world are usually more comfortable in their own language. Okay, so if you want to have software in China, you better have a person understanding Chinese, talking in Chinese. Okay.
Actually, sir, have you done the survey for the payback time of the software with the foundries?
We haven't done that, but I have values of that. We have been asking people, and at least I know for AutoCAD, I know. AutoCAD's payback period has been ranging anywhere from 7 days to maximum about 6 months, 9 months. Very rarely we have seen people saying it is more than 1 year. That is for at least for our software. Other software I do not know, because they are more expensive, but then we are talking about tangible benefits here. You can also have intangible benefits from software. Okay, what are intangible benefits? You may say to a customer that I have this particular software, let's say Procast or Flow 3D or something, and because you say we have software, customer says, okay, I'll give you an order. So we are not counting those benefits. Okay. One more big intangible benefit is that, in fact, let me tell you that I did come across one foundry man in Chennai Congress or something, where they said, yes sir, we are getting orders and all that. But I said, so how much you got the real benefit out of shrinkage, quality improvement or yield improvement? So I said, we are not really using the software. We are keeping it and we show it to customers when they come to our place. So that's marketing. It's like ISO 9000 I mentioned to you earlier. So we Indians are smart, so we'll use. Once we invested, we'll somehow get the value out of it, So we know how to do that. And let me just, you please remember a question. One more important non-tangible benefit we see is that foundries which are using CAD and simulation and IT in general, we find, and you can make out when you go to foundry and you talk to people, even for 1 hour, half an hour, you'll know that. There's a big cultural difference I see between those two foundries. The difference comes in the way people discuss a problem. Okay, in foundries which do not have IT and simulation and CAD CAM, there's always some person who says, no, I know from experience this is how it happens. Okay, whereas in the foundry where they say, sir, we tried to put that, we put the gate there and we saw the flow vectors were like that. The quality of discussion itself changes. You are doing it in terms of numbers, you're doing it in terms of quantitative measurable parameters and not I think so or I am experienced or I know better, you don't tell me kind of a discussion. The quality changes, and that has a major impact on the morale of the younger engineers, and that I think is a major intangible benefit which you can't measure in terms of yield improvement and quality improvement. Okay, so let me close this session here, and what we looked at is that these simulation packages may be difficult to procure in the beginning, maybe you have a lot of manpower issues in the beginning, but they do give you benefits in the long run. Not only tangible benefits like quality and yield improvement and reduction in development time, but also intangible benefits like better image, better marketing, better morale of the company and people in the company. Okay, and typically the return on investment you have asked is typically most of these packages claim 1 year, and we have seen in our own case it can be anywhere for a few weeks to few months. So usually ROI is not an issue, it's the manpower which is an issue, and if you can tackle that, then you are doing fine. Also we looked at IT, how it has grown over the years, and I am very happy to say that India, which is now called as one of those IT superpowers, we are finally beginning to see the penetration of IT tools in our own foundry industry, we say mother industry, right? And only thing is we need to always worry that most foundries do not necessarily get younger engineers all the time. So it's not only important to attract fresh talent, which is getting more difficult, but also to retain and retrain senior engineers. So you find that it is far more easier to teach computers to a foundry person than to teach casting to a computer person. In fact, it's a good idea to always to hire your retired employees and come back and say, okay, fine, to start preferably documenting your experiences, because most experience is sitting in their head. You have to start documenting that. Every story is a case study, anecdote, an experience to apply to a new case. Okay, so with this we'll stop.